Hi everyone, and welcome to this first lecture where we are going to build the algorithm for the application. In this case, we are using the particle swarm optimization algorithm. Here in the first class, we are going to establish some hyperparameters and create the function for each particle. First, let's import some libraries. Import random, the random module. We are also going to import the numpy module, and we are going to import the matplotlib.pyplot as plt. And here some hyperparameters. Let's establish the inertia as 0.8, C1, which is the cognitive weight, as 0.5, and also the social weight as 0.5. Now let's establish the function for the particle. Let's remember that a particle in this problem can be modeled like this. We can create a function. It can also be used object-oriented programming. Here I'm just using a function and instances of functions. And here we have a data structure where we have three indices. In the first index we have position 1. In the second index we have current position or position 2. And in the third position, we have the velocity. Let's create the function for the particle, def particle. Here, let's put an infinite loop, while true. Particle is an empty list. Here we have position 1, and here we have position 2. For I in range 6, rand equals random.randint 0, 3 plus random.random. So here we have the number of hours that we will put randomly for each position for each day of the week. So here I'm going to choose 0 from 3 hours, and in this part right here, random.random, we have from 0 to 1. So this whole value can range from 0 to 4. I'm going to define a second random variable, rand2, and these will be the positions. So pos1.append rand and pos2.append rand2. And here outside the loop we have the velocity. Because we have 6 times during the week, we have 6 possible positions. So I'm going to put 6 zeros. 1, 2, 3, 4, 5, 6. Now let's build this particle right here, this whole particle. Particle.append pos1, particle.append pos2, and particle.append val, which is velocity. And here we have a condition. If sum particle 0 less or equals 13 and sum particle index 1 also less or equal 13, then we are going to break the loop. Why we establish this condition? Because we cannot have more than 13 hours. We have a total of 13 hours to distribute throughout the week for the classes. Before the break, let's return the particle. And now let's execute the code. Let's create a particle x. Let's print x index 0, the first position. Let's print x index 1, the second position or the current position, and let's print x index 2, which is the velocity. Let's print. So here we have the first position, this part right here. Here we have the second position or the current position, which is this part right here. And here we have the velocity. In this example, we only have 2 dimensions, and the problem in this example image. However, in this problem, we have 6 dimensions. We have 6 different variables. So this is the velocity. In the next lecture, we are going to build a function for the population of particles. I see you in the next lecture.